Alright guys, so we worked on solving these rational equations yesterday, and we're going to continue doing some today. So we're going to do 4 more today, and this is the first one we're going to look at. And again, when we look at solving any of these here, we want to get rid of any fractions, because it's going to make it a lot easier to work with if we don't have any fractions in the denominator. As we look at this here, these here, unlock this, move it down a little bit. Now we lock it in place. When we look at these two here, well, the first one, 4 over y minus 4. Well, if I multiply this by y minus 4, the y minus 4 and y minus 4 will cancel here. Well, if I do that to one term, I have to do it to everything. Because again, whenever we're solving these rational equations, we want all the denominators to simplify. Well, that won't simplify the 3 over y minus 3. Well, what will would be y minus 3, because this y minus 3 here and this y minus 3 here would cancel. And when I do to one term, I have to do it to everything else. And now the 1 over here doesn't have a denominator, and so that's going to be it. Now if we look at here, look at each term and see what simplifies. Well, here we said the y minus 4 and y minus 4 would cancel. Excuse me. And that would leave us with 4 times y minus 3 minus. And in the second set of parentheses, or the second, not second set of parentheses, the second rational expression, the y minus 3 and y minus 3 would cancel, leaving us with 3 times y minus 4 equals, well, there's no simplification on this right-hand side with the 1, so we're just left with 1 times, well, y minus 4 times y minus 3. And because it's multiplied by 1, we really don't have to write the 1 back in. We can just leave it as y minus 4 times y minus 3. Now we just need to solve. Well, the first thing we can do is we can distribute the 4 through. And if we distribute that 4 through, well, 4 times y is 4y minus 4 times negative 3 would be negative 12. And we get that there. So the next thing we can do is distribute the 3, negative 3. And if we distribute that negative 3, well, negative 3 times y would be negative 3y. And negative 3 times negative 4 is going to be positive 12 equals. Same thing over here. We've got to distribute the y and then distribute the negative 4. We're multiplying all the way through. So if we do that, y times y would be y squared. All right, have to use my hypertext. Y squared. Y times negative 3 would be negative 3y. And then we're going to do negative 4 times y, which would be negative 4y. And negative 4 times negative 3 would be positive 12. And once we finish multiplying everything through, we get this here. Now at this point here, we can combine like terms. Well, we have 4y minus 3y, and 4y minus 3y would be y. Negative 12 plus 12, well, that would just be 0. So on the right-hand side, not left-hand side, sorry, left-hand side, 4y minus 12 minus 3y plus 12. When all that combines, like terms combine, we just get y. Now on the right-hand side, the other side, we have y squared, because there's no other y squared terms over here. Negative 3y minus 4y would be negative 7y plus 12. Now again, we have a quadratic. a quadratic term, our y squared term, so we need to get everything on the same side of the equal sign to be able to solve. And to do that, we need to subtract y from both sides, because y minus y would cancel. And again, the reason we're getting everything on the same side is so that this is set equal to 0. And over here, we're going to have y squared. 7y minus y would be minus 8y plus 12. And we get this here. So we're almost done. We just need to solve this for the value of y, find what values of y will make this equal 0. And the easiest way to get this is to factor it. Two sets of parentheses, and we want to find out how this factors. So when we look at this here, we first normally look to see, is there a greatest common factor between any three terms? And there's not. There's not a greatest common factor between y squared, negative 8y, and 12. So we set our two sets of parentheses. Now because the 12 is positive, the signs are the same, and they match the sign of the middle term, which would be negative and negative. Now we can find the factors of y squared, which would be y and y, because those are the only terms that multiply together to give us y squared. Now we can find the factors of 12. So we're trying to find two numbers that multiply together to give me 12. So we have 1 and 12, 2 and 6, 3 and 4. And the ones that are going to work well are 2 and 6. This negative 2 times negative 6 is positive 12, and negative 2 minus 6 is negative 8. So these are the two that we get here. And now that we have it solved, we have two things multiply together that equal 0. Well, it means that one of them has to be 0. Either y minus 2 is equal to 0, or y minus 6 is equal to 0. One of these has to be equal to 0. Whenever we have two things multiply together equal 0, one of them has to be 0. At this point here, we can solve for the value of y. So first here, we can add 2 to both sides, which tells me y is equal to 2. And over here, we can add 6 to both sides. And when we add 6 to both sides, we get y is equal to 6. So these here are our two answers. And we didn't check restrictions, and we should have. I should have checked restrictions first, because we have y is equal to 2 and y is equal to 6. Now our restrictions for this here, well, here we have, erase these lines so we can see it a little better, y minus 4. Well, if y is 4, well, 4 minus 4 would give me 0. So y cannot be 4 for that one there. Here we have y minus 3. Well, y cannot be 3 because 3 minus 3 would give us 0. So in this one here, y cannot be 4 or 3. If we look at our answers, 2 and 6, either one of those is a restriction. So these here are our two answers. And that's all we have to do for this here. All right, let's look at this one here. This is our next one. Now, if we notice, we do have multiple variables in each one of these spots here. So what's going to be helpful for some of these here is if we factor, because if anything is factorable, we need to factor it, and it's going to make it a little bit easier to work with. Now, as we look at this here, well, we don't care so much about the numerators factoring, it's more the denominators. Because again, we're wanting to multiply each one of these by something so that the denominators will simplify out. And we want to multiply only by the smallest number of terms, the simplest amount, because anything above that's going to make these problems a little bit more complicated. Now, if we look at all this here, x plus 1 is as simplified as it gets, x is as simplified as it gets, but x squared plus x is not. Because between these two terms here, we can't factor it by two sets of parentheses, but there is a greatest common factor between them. And our greatest common factor between x squared and x is, well, just x times x plus 1. So when we factor in x out of x squared plus x, we get x times x plus 1. And now it's all simplified. And now that we have all this simplified down, it's going to be a little bit easier to work with to see what we need to multiply each term by so that all the denominators simplify. Now we can start with kind of the most complex one, the x times x plus 1. And yes, we're going to multiply each one of these terms by x times x plus 1 at least. It's a little sideways. Because if I multiply the middle term, 1 over x plus 1, x times x plus 1, by x times x plus 1, this here and this denominator would simplify out. And if I do it to one term, I've got to do it to all three. So I don't have to do it to the middle term, but I have to do it to all three terms. And the reason we're doing this is because, well, x times x plus 1 would cancel with x times x plus 1. That would get rid of the fraction here in the middle. Now let's see if it simplifies everything else. Because if it does, we don't have to add anything else. We don't have to multiply these by anything else. But if we're missing something, then we would. Well, here the x plus 1 and x plus 1 would cancel. Hey, I don't have any more fractions here. And the last one, x and x would cancel, and that simplifies all the fractions there. So multiplying each one of these by x times x plus 1 does simplify each and every fraction out. So let's see what we're left with. Well, in the first rational expression, the x plus 1 and x plus 1 cancel, leaving me with 2 times x minus. Well, the x plus 1 and x plus 1 canceled. Everything canceled out except for 1 equals. Here on the right-hand side, x and x canceled out, but I'm left with 3 times x plus 1. And that's all that's left over after we did the multiplication through. And now we can solve. But again, we need to consider our restrictions. Because what did we simplify out of the denominator? Well, we simplified out an x and an x plus 1. Well, this x and x plus 1 are just repeated, so we don't need them twice. Now, what value of x is going to make x 0? Well, 0, because x is by itself, so it would be 0. And our x plus 1 would be negative 1. So if we get 0 or negative 1, they will not work. Okay, I know that was a little bit of an interruption, but those are our restrictions, and we have them now. Now we just need to find the value of x. Now the first thing we need to do is we need to simplify these parentheses so we can multiply through by 3. And if we do that, we'll still have 2x minus 1 on the left-hand side. But on the right-hand side, 3 times x is going to give us 3x. Plus 3 times positive 1 will be positive 3. So we multiply through by 3 first. Now the next thing we need to do is we need to get all the variables on the same side. So we can subtract 2x from both sides, because 2x minus 2x would give us 0. And we subtract 2x from 3x. And if we do that, we would get negative 1 is equal to, well, 2x minus, or 3x minus 2x is going to give us x plus 3. Now again, we're almost done. We still need to get the variable by itself. So what I can do is I can add 3 to both sides. And if we add 3 to both sides, add 3 to both sides, subtract 3, because since 3 is positive, we need to subtract it, not add it. So 3 minus 3 would give us 0. If we added it, would have given us 6, so that doesn't work. So 3 plus negative 3, or 3 minus 3 would give us 0. Negative 1 minus 3 would be negative 4. So we find that the value of x is -4 when we solve for this here. And since -4 is not one of our restrictions, 0 or -1, this works and it is our solution. And that's all we have to do for this here. We have finished solving this one here. All right, we've got 2 left. We got this one and one more, and then we will be done for today. So, when we look at this here, we're going to solve it. The first real thing we need to do is simplify any of the denominators. Well, this one here and this one here will simplify a little bit, and once we finish simplifying it and figuring out what we multiply it by, we can find our restrictions, so we know what values of x we cannot have. And then we have a plus sign here in the middle. Now we look at all of these here, well, the numerators, none of them are going to simplify, so we'll leave them as x, 1, and 1. And x plus 2 is not going to simplify. That's as simplified as it gets. Now when we look at our first one, 5x plus 5, it will simplify because there is a greatest common factor between these two terms, and that is 5. So if I factor it out, I'm left with x plus 1. So when I factor 5 out of 5x plus 5, I'm left with x plus 1. Now we can factor the second set, this x squared plus 3x plus 2, 2 sets of parentheses. Because the 2 is positive, the signs are going to be the same and they're going to match the sign of the middle term, which is going to be positive and positive. Now our factors of x squared are going to be x and x. And then the only factors of 2 are 1 and 2. And this here is as simplified as that gets. That is factored. So we have this here. Now we're going to do this a little more streamlined than I did it last time. So we need to find our restrictions. Well, there's only 3 spots, or 2 spots really, where x can cause, plugging in a value of x, that would make this 0. And that's at our x plus 1 and x plus 2. Well, with x plus 1, the value of x would be -1, because -1 plus 1 is 0 in both of these spots. Now in x plus 2, our value of x would be -2, because -2 plus 2 is 0. So if we find out that x is -1 or -2, that solution will not work, because it's going to cause the denominator to become 0. And that's going to be our restriction. Move this down just a little bit. And now we need to see, what do we need to multiply everything by so that the denominators simplify out. They reduce out completely, so we don't have any fractions left over when we are solving. So we look at all this here. Well, I'm going to look at this big one here. So we have x plus 1 and x plus 2. So I know for sure plus 1 and x plus 2. We'll have both of these here being multiplied by everything, each one of these terms, because we needed to simplify this out. Now if I look at this middle one, x plus 2, well I already have an x plus 2, so we're good there. But the first one here does have something a little bit extra. It has the 5. So I'm going to need a 5 also. So what I need to multiply each one of these by is 5 times x plus 1 times x plus 2. And that's what we need to multiply each one of these by. So we're going to end up multiplying each one of these terms by 5 times x plus 1 times x plus 2 to get the denominators to simplify. And we look at this here, so when we simplify 5 times x plus 1, 5 times x plus 1, those would simplify. X plus 2 and x plus 2 would simplify. And here x plus 1 and x plus 2, both of these would simplify out. And that's it with our simplification. Now we still need to solve, but before we solve, we need to see what we have left. So in our first one, well, 5 times x plus 1 canceled out, leaving us with x times x plus 2 equals, well, 1 times 5 times x plus 1, No, that's just going to be 5 times x plus 1. Well, wait a minute. Didn't we already know what 5 times x plus 1 is? We got it from right here, and that's just 5x plus 5. So if something ends up being left over that we simplified, so we factored 5x plus 5 down to 5 times x plus 1. Well, heck, I have it right here. 5 times x plus 1 is 5x plus 5. We can go on and put it back in. Plus 1 times 5 is 5. So once we multiplied through by 5 times x plus 1 times x plus 2, we got x times x plus 2 equals 5x plus 5 plus 5. So it simplified down so that I don't have any more fractions. We don't have any more rational expressions in this equation. So now we can go on and solve. Now the first thing in solving is going to be kind of distributing these here, getting rid of any sets of parentheses that we have. So x times x would give us x squared. And x times 2 is going to be plus 2x equals. Well, here we can go on and combine these like terms, 5 and 5. It'll give us 5x plus 10. So we have this here. Now, because we have an x squared term, we need to get everything on the same side. So I'm going to move everything from the right side to the left. And that's mainly just to keep the x squared term positive. I feel like it's a little bit easier to work with if the x squared term is positive. So we can subtract 5x from both sides. So 5x minus 5x would simplify. And that would leave us on the left-hand side. We'd have x squared minus, because 2x minus 5x would be negative 3x, equals 10. So we're almost done getting everything on the same side. I just need to subtract 10 from both sides. Because 10 minus 10 here would simplify, it would cancel out. And what we're left with is x squared minus 3x minus 10 is equal to 0. So we have everything on the same side of the equal sign. And that's what we wanted. So we multiplied through to reduce all of the fractions. Then we moved everything all over to the same side because it is a quadratic. And what we could do now is we can factor these. Because x squared minus 3x minus 10 will factor. And if we look at this here, well, since the 10 is negative, our signs are going to be opposite. One is going to be positive, and one is going to be negative. Now, if we look at the factors of x squared, well, we have x and x. And now the factors of 10. Well, the factors of 10 are 1 and 10, or 2 and 5. 2 and 5 are going to be the ones that I think would work. And we're going to take positive 5 and negative 2. And those two will be the ones that work. Because 5 minus 2 would give us, actually that wouldn't be quite it. It would give us positive 3. And that's a good thing that we checked, so we would switch it and have positive 2 and negative 5. That's always why we want to check and make sure when we multiply through it does work out. Doing this here, giving us negative 5x plus 2x, because if we did it the other way, it would have given us positive 3x, not negative 3x. So that's a good thing I checked, just to make sure. And now we do have the correct setup, the correct factors. X plus 2 times x minus 5 equals 0. And lastly, in solving, because I have two things multiplied together equals 0, it means one of them has to be 0. So either x plus 2 is equal to 0, or x minus 5 is equal to 0. One of these has to be equal to 0. So we set them both equal to 0, and we will solve. So for the first one here, we would subtract 2 from both sides. And when we subtract 2 from both sides, we get x is equal to negative 2. So that'd be one of our solutions. And our other solutions here, we would add 5 to both sides. And we add 5 to both sides, well, these would cancel, giving us that x is equal to 5. And that's it. That's all we have to do for this problem here. And if we look back at our restrictions, well, our restrictions were -1 and -2. Well, hey, -2. So this here will not work. So our only solution this time is 5. Even though we got 2 answers, because one of them is one of our restrictions, it does not work. So our only value is x is equal to 5. -2, since it's a restriction, it does not work. So our solution is x is equal to 5. And that's all we have to do for this one here. And so that brings us to the last problem of the day. This will be the last one that we look at. And then we're going to be done. Now, if we notice here, x minus 2, x times x minus 1, x times x minus 1 times x minus 2, the denominators are all factored. We don't have to factor or simplify anything here, so that part is done for us. That's kind of nice. Which means we can go on and kind of look at our restriction, see what x cannot be. Well, here, since we have an x by itself, well, that automatically means 0 is going to be one of our restrictions. Now we have an x minus 1 and x minus 1, so that means 1, because 1 minus 1 would give us 0. And our last spot is going to be x minus 2. That's going to be 2, because 2 minus 2 would give us 0. So our 3 restrictions that we have, and we have 3 of them, would be 0, 1, and 2. So if we get any one of those 3 values as a solution, they would not work. Now what we need to do is we need to find out what we need to multiply each one of these terms by so that the denominators will simplify out. Well, I'm going to go on and just look at the most complex one we have here, because we have x times x minus 1 times x minus 2. And if we multiply this by our 2 over x times x minus 1 times x minus 2, the entire denominator would simplify. And if we do it to one term, we've got to do it to all 3. Do it to this one here, and this one here. Now if we look at the other ones, x times x minus 1, okay, that would simplify everything out, and our x minus 2. So it worked out just grabbing this biggest one here, simplified everything else. As we look at it here, well, x minus 2 and x minus 2 would cancel. I've simplified everything in the denominator of our first term. X times x minus 1 and x times x minus 1 would simplify. Okay, everything in the second term simplified. And everything in the last term will simplify. In the denominator at least. And that's quite handy. So it worked out that multiplying everything by x times x minus 1 times x minus 2 would simplify the denominators out completely. And let's see what we're left with. Well, in the first term, we're still left with x times x minus 1 plus. In the second one, we're left with 2 times x minus 2 plus 2 equals, well, okay. I did forget to multiply it one more time because, again, we need to multiply it by every single term. I have to move our restrictions out of the way. Because I still need to multiply this by what this is equal to. And what that would give us is 0 times x minus 1 times x minus 2. And that's going to simplify out. I know that most of y'all are saying, okay, doesn't that simplify to 0? Well, yes. Because anything multiplied with 0 is just 0. So all of this here becomes 0. So we can multiply all this with 0, and it just becomes 0. And that's one of the real nice things with 0. Okay. So now we've simplified it down. We don't have any more fractions since we multiplied everything by x times x minus 1 times x minus 2. which is really nice. And now we just need to finish solving this. So the first thing we can do here is multiplying through by x, and multiplying these two here by 2. And if we do this here, x times x would give us x squared. X times negative 1 would be negative x. 2 times x would be plus 2x, and 2 times negative 2 would be negative 4. Plus 2 is equal to 0. So we finished multiplying through there. Now we can combine like terms. Well, there are no other like terms with x squared, so it's by itself. Negative x plus 2x will be plus x. And negative 4 plus 2 will be negative 2 is equal to 0. So we combined our like terms. Negative x plus 2x and negative 4 plus 2. And once we finish combining like terms, we get x squared plus x minus 2 is equal to 0. And now to finish up solving, we need to factor this, because once we factor it, we'll be able to solve for the value of x. So we look at this here, since 2 is negative, we're going to have positive and negative. The signs are going to be opposite. The factors of x squared are going to be x and x. Now we need to look at the factors of 2, 1 and 2, and we need them to be positive x. So, positive 2 and negative 1. And if we check this, negative x times negative 1 would be negative x. 2 times x would be plus 2x. And that would give us a positive x that we wanted. So it works. So those are the factors that we wanted. And now because we have two things multiplied together equals 0, it means that one of them has to be 0. So either x plus 2 is equal to 0, or x minus 1 is equal to 0. One of these has to be 0. Now we just need to solve. So for the first one, we can subtract 2 from both sides, because negative 2, or 2 minus 2 would be 0, leaving us with x is equal to negative 2. So there's one of our solutions. And for the other one here, we can add 1 to both sides, because negative 1 plus 1 will simplify out, will become 0. And give us x is equal to, well, 0 plus 1 is 1. So these here are our two solutions. But if we look here, well, 1 is one of our restrictions, so x cannot equal 1, so that does not work. Which just leaves us with x is equal to negative 2. And that is our answer. And that's all we have to do for this here. Now, I'm not going to give you another worksheet for trying to solve these here. So I'm just going to have you go on and continue doing any of the homework that you haven't finished, solving the equations, the two worksheets, and anything on Big Ideas Math. So the Big Ideas Math assignments already has a solving one, so you'll do that there if you haven't already done it. So you have those there, and the two worksheets that I submitted last week or assigned y'all last week. And if you have any questions on any of that, please ask. But that is it for what we're doing today.